Good afternoon. In this video, we are going to talk about proposition 43 from book 1. So before we start the proposition, I would like to introduce a concept. It is called complement. So for example, if we are talking about the complement of parallelogram, then the shape of this complement will also be parallelogram. And in this proposition, we will talk about complement about diameter. So for example, we have a parallelogram ABCD, and we construct a diameter BD, and we randomly pick up a point P from BD, and if we make, let's say, two straight lines that are parallel to two adjacent sides of this parallelogram respectively, and then the shaded parts are so-called complements of parallelogram about diameter. Okay, this is the concept. So the proposition 43 states that the two complements about the diameter of a parallelogram are equal. Okay, so it states this GAEP equal FPHC. Okay, so let's give it a proof. So first of all, please recall proposition 34. The diameter of any parallelogram will bisect the area. Okay, so please know that these DGPF and PEBH are also two parallelograms, because GH, AB, DC are parallel, and these three lines are also parallel. So for this parallelogram, we have that triangle GPD is equal to triangle FDP, right? Because of proposition 34, this diameter bisects this parallelogram, right? And similarly, we know that PEB will be equal to PHB, right? These two triangles. And if we combine them together and apply proposition 2, we add the equal things to both sides of this equality, the results are also equal. So we have GPD plus PEB will be equal to FDP plus PHB, right? So this plus this equals to this plus this. Great. And in the whole parallelogram ABCD, we know that this big triangle is equal to this, still because of proposition 34. We know that ABD will be equal to CBD, right? And then let us apply common notion 3. At this time, we subtract the equal things from the equal things, so the results will be equal, which means ABD minus this will be equal to minus right? So this equality also holds, which means the big triangle minus two small triangles are equal to this big triangle minus these two triangles, which means these two shaded areas are equal. So we have AEPG. This complement is equal to another complement FPHC, and this is the end of our proof. Great. So in the next one, we are going to talk about proposition 44 from book 1. Thanks for watching. Have a good day.